Okay, everybody's here. Um, we will continue with last time's lesson. I'm not going to be able to go the whole time. I woke up with a really sore throat this morning and it's not getting any better. So I'm waiting to get done with you guys and then take massive amounts of drugs and hopefully sleep it off. So, um, unless I got the COVID and I'm going to be dead in 3 days, in which case I'll go ahead and enter the grades now so that you don't have to take the class again. But I don't think it's that because I didn't get exposed anytime recently, unless Weston gave it to me. But we didn't get that close to each other. Uh, Plus, it was windy as hell that day.
I wouldn't have been out and about if I had it. I would have known. I
Yeah,
knew last time, so
yeah. I don't worry about it out there because I've never been out there when there's not a 20-mile-an-hour wind from some direction. So that'd be a hell of a virus to be able to swim through that much wind and get to you. So I think it's just I think it's the it was chilly today and there's pollen. All the trees are mating in the air that I need to breathe. So uh, but y'all had good reactions to that. Okay, that's funny. So what I've done since last time is I didn't think it would be fair to let you all proceed completely on your own, although I guess fairness doesn't really matter. So I decided I was going to see if I could model some cases, and all I've gotten to is the railroad yard. So I'm working up in this area, and on the screen you should be seeing the cursor migrating around, making me nauseous for once. That's unusual. I've changed these subcatchments. I've added a LID control. Now, if you all have done this on your own and figured out, kudos to you, because the examples we have to work with that I found on the mighty internet, and if it's on the internet, it's got to be true. Bonjour. Um, it's an old commercial, not that old, but that should have been as funny as plants messing around in the air that we're breathing. The only example I found that showed the input editor has this BMP editor. And if we look over here, it's part of hydrology. But if we go to our variants of swim, which are a couple of versions later than this one in the example, there is no BMP up there in the hydrology. And let's check the hydraulics. The only place it would be in a node. There's nothing interesting there. So what I think happened is they renamed BMP to LID. MICKEYMOUSE. Okay, so then they renamed it to low impact development, and I'm betting in your guys' careers it'll get yet another name. It'll somehow become gastroenteritis, green infrastructure. Okay, naming aside, here was the clue that I found in the reading was that. And what's going on that's unknown to y'all is the author of this is Louis Rossmann, who is one of the primary programmers of the interface for Swim. So all this graphical junk, he wrote the programs for it. And if you happen to have the $8,000 piece of software from Embarcadero Software out in California that lets you take the Delphi files, which is the language he used to write this in, you can recompile it on your own. And so he at some point changed the name, recompiled it, and that's what we have access to. So all the source code's there, but Embarcadero, even Louis Rossmann will tell you, they're the worst software business on the planet to work with. They make the Russian Federation cyber hackers that are going to take down all the infrastructure of the world, seem like nice guys. So recompiling these interfaces is not trivial. I'll brag on myself. I've done it once, and I would show it to you, but it looks just like this. I did it in Delphi version 8. I couldn't get it to work in 10.2, so I had to go back a couple of prior distributions to be able to recompile the interface. I only did that to prove to myself I could. I didn't change anything. And I had the $8,000 piece of software. So redoing interfaces is not something that we can ourselves expect to have to do very often. We will hire a genius or a thief to do it for us. So with that aside, the whole point of the story is LID controls and BMP editor appear to be doing the same thing. So when we go to LID controls, when you first open it, it'll look like this. I have two versions of Swim open. One of them is the base case. One of them is Railroad. Let me resize that. So we go to LID controls and you see it's blank. And you go, that's not very useful. At least that's what I went. Until I saw this little green plus sign. And plus, like I said, I have compiled one of these interfaces before. And it's like, oh yeah, you got to add the object. And so you click on the plus sign. I'm going to do it over here where I can't do any damage. And you get the LID control editor. So that and that don't look all that alike. But let's pick a option. Let's go with a green roof just for fun. And now all of a sudden, it's starting to have similarities because it's asking for, in this case, it has depression storage, weir coefficients, flow widths, maximum depth. And this one has berm height, vegetation volume, soil properties, drainage map. It's like, aha, this is how I create my LIDs. And these are the choices. I have a vegetative swale, which actually doesn't do very much interesting. Rooftop disconnection. And what I'm looking for in the tab sheets, because I'm too lazy to go search in the internet and read exactly how it's modeled, although I'm pretty sure it's described in enough detail here that any one of us could figure it out. I'm looking for something that has the ability to affect water quality. Rain barrels do, but putting rain barrels on a railroad yard is going to be stupid because all they will serve as is targets for the local marksmen in the neighborhood practicing for their drive-by on the weekend. Permeable pavement has pollutant removal. Infiltration trench. Green roofs don't. Rain garden doesn't. Bioretention cell does. And these are all variants of one another. If we go look at the, see what does the generic one, and it has the pictures. Oh, crap. Oh, that was on recording, wasn't it? Ah, feces. Same thing. These are photographs of the various kinds of green infrastructure LID units that are straightforward models using SWIM. Rain barrel, but it doesn't have to be this polyethylene barrel. It could represent a large cistern or a tank like a tank that they have out in ranching country. A rain garden is just a bunch of weeds that are throwing pollen in the air so you can't breathe. Vegetative swale is a really elegant name for a V-shaped ditch with a bunch of grass in it. Every one of us in Lubbock that's living in actually even apartments have, if you're living in Lubbock and you go to your back alley, which is if you're in a house, that's the place where you take your trash and try to find the empty dumpster along the back alley. And it's usually a competition between you and the various yard care people that fill the dumpsters up after the garbage truck comes through. That's a vegetative swale. Now, not as nice as this picture, because in Lubbock, if you will recall your last time taking the garbage out, most of the vegetative swale is 2-track dirt path from the garbage trucks going there twice a week. There's a little green stuff in the middle. In the case of my backyard, there's a pile of broken glass at each end of the dumpster, and there's a couple of gas meters sticking up out of the ground, electricity, and then there's grass along the edges and the various back fences. But that's an example of something that could be classified as a vegetative swale from the standpoint of water quality enhancement. A street planter and a rain garden are probably going to function the same way in the swim model. Permeable pavement, infiltration trench are going to have some commonalities. And so if we bioretention cell, do I have a picture of one? Bioretention cell and a street planter are probably going to be similar. We'd have to do some reading on this. So bioretention cell, I know, is a renaming of something that we all know of as something common and boring. So bio has something to do with life, and retention means you put a bunch of living stuff in this hole in the ground, and it magically makes water yummier. And I'm sounding cynical. These have been documented to work. They're pretty effective if you can get them at scale. Rain garden, green roof, infiltration trench. And because of all this pretty drawing that's gone into the interface, I have to imagine that somewhere is a user manual that correlates to these drawings and will assist us in doing data entry. We have this drain advisor right here, which is actually appropriately named. That was pretty genius, Mr. Rossman. That gives you advice on, I guess they're saving you time on having to reverse engineer what every setting does. Oh, that's better. It has descriptions of the different parts of the LID. So I would think between this and an online literature search, it would not be terribly difficult to concoct your own personal tutorial on how to parameterize these things to accomplish the behavior you want. And then having said that, I've not done that yet. But I think this is well within our collective capabilities if necessary. What I have done is I just pulled some numbers out of my datum, or you could think of another place to pull numbers from. That's where they came from, and created a rail yard infiltration. I played with swale, and it took me about an hour before I realized it had no impact on water quality because it didn't do any pollutant removals. So I created this infiltration one, and the cool thing is you can give them different names. So we can have railroad biocells. I'm not going to change the parameters. This will be a useless one. It's not going to let me. This is when you're looking for the FU button in the software, and I can't find it. So I've created a rail yard biocell, and then if I want to have a green infrastructure unit that has different behavior, but it's the same type of unit, I give it a different name. Use the evergreen cemetery. And what I'm going to do is I'm going to dig up all the dead bodies in the cemetery and carefully preserve them long enough to go back and put 12-inch berms around the cemetery, get my vegetative fraction to about a third. A manganese roughness of 0.1 seems awful large to me. This is pretty flat area. And then the soil, I'll put 12 inches of soil, 50% volume. I'll leave all those alone. Storage, 8 inches. Drain, I'll leave that at a 0 because I don't want to go bother with parameterizing it. And I'm going to make this thing really good at removing pollutants. Now, keep in mind, these are not design inputs. I can type 99% removal. That in no way, shape, or means that you can actually build something that does that. So you would select removal fractions that make sense and are defendable based on either laboratory studies that you've done, field studies that you do for the project, or literature studies. I think bioretention cells are pretty good at TSS removal, so I'm going to put it at 80%. But again, in a professional application, I can put the 80% there. I'll need to be able to back it up with a reference list in the report. Choose the okie dokie, and now I have a bioretention cell. As of now, it's just sitting in the database. We have to go ahead and apply it. Oh, let me go ahead and do my 2 runs. So link 100 is right about here. And I have it in both, well, obviously I have it in both models, maybe not obviously. And I'm plotting the TSS. At first glance, they don't look much different until you look at the scale. So prior to putting in our green infrastructure, our computer program is predicting 450 milligrams per liter going down that conduit. And after we put in all that in, I put 25% coverage on every one of the subcatchments that touch the railroad yard. I'm able to knock 50 milligrams per liter off the pollutograph. And so that's somewhat promising. That does imply to me that the computer program has sensitivity to any green infrastructure inputs. And if I look at the total areas that are involved, 12 acres, that one's probably 16. So we're looking at probably 1, 2, 3, 4, 5, 72 to 100 acres of many hundreds of acres. And I'm taking 25% of that and applying some sort of green infrastructure treatment. And I get a change relatively close to the infrastructure. When I move away, link 281 is down here. So that's, once that's integrated, all the inputs for the watershed, the pictures to me look almost alike. And I don't think they're identical, but they're peaking above 180 and at about the same time. I can't tell if they're not identical unless I actually produce a time series table. I don't think that is, I don't want to do that. But let's go ahead now and add some more capabilities. Let's suppose that we can take this whopping 24 acres, and now we're going to add a control. And again, this was reverse engineered. You get this sign, you have to go on faith and click the button add, and then you get to choose from the list of controls you've already created. And then you have a choice. You could occupy the full subcatchment, which I want to do with my cemetery. I'm going to dig everybody up, put in this fancy bioretention cell, and then stick all the bodies back in place, regrade it, put new headstones on it, have a little cappuccino bar for the families that visit, and also a flower concession. And so what was a nice cemetery, we make it even better, and it's producing water quality benefit. And we'll let it treat everything that comes into it. So again, I'm making these numbers up right now just to reverse engineer how this thing works. So that's going to be a pretty impressive bioretention cell. See, that one is on the Hughes property. We included that as an option, didn't we? So let me go ahead and do the same to that. But the Hughes Street property, you're not going to tear up buildings to do LID stuff. And so instead, you're going to maybe find 100 square feet here and there, and maybe find a way to install 15 or 16 units. I'll make it a 70 feet wide. I don't know what it uses the width for. And again, we'll have it treat everything that comes to it. So my infiltration thing doesn't perform as well as my evergreen cemetery. It doesn't have the same capability. So we've done that, and we could do these remaining ones. Might as well do those, and then we'll see what we get. And again, to make this more intelligent, we'd actually want to create the infiltration trench and call it Hughes Complex Trench or something like that. I'm just using the railroad one anyway. And remember, I gave ourselves an upper limit of up to 25% of the catchment can be used. We will assume it can treat everything it takes. I'll stop there and I'll just run those two. So now we have 2 of the 3 areas incorporating some kind of low impact development. And if we go up to link 100, there should be no change there because we just put stuff downstream of that location. If we go to our link 281, cool. I am impressed. So didn't really take that much area. So the total amount of areas that we actually put under green infrastructure control for that whole drainage area, that whole country club Bayou area, the total amount of area that we put under lid control is actually pretty small. Maybe collectively 100 acres out of, there's probably 1,000 or so acres there. It's a couple square miles. And so we've only taken a small portion of it, and we're able to, if we trust our computer program, we're able to make a meaningful difference in the total suspended solids going to the bayou. Now it's only a couple of milligrams per liter. So in terms of milligrams per liter, it's like, nah, but in terms of actual mass loading, it's probably substantial. So let's suppose at this point I am curious about what the actual difference is. That's where we go to a different tool and pull out our time series table. Hopefully this will work right. So there's my link 281 TSS in my pre-infrastructure model. And then when I went ahead and spent a lot of money, I now have my post-infrastructure model. And let's go. Oh, that's right. It's this crappy EPA. One thing I detest about the time series is how to get to the next day. If we go all the way down here, we're just at the end of day one. So we have some difference. And then how did you do multiple days? Do you remember how to do that? Do I do this? Maybe I got to do it by object. Time series table, object.
Yes, I was going to mention.
Pity it doesn't let me change the end date. Huh. Well, there's the problem right there. Is it's not letting me change the date. Another thing to report back that's it's still broken.
Does it have anything to do with the input file, with the date?
No, the input file. Oh, wait a minute. I was being an idiot. We only have 21 hours of simulation, so it shouldn't let me change the date. Okay, so my date is correct. Choose OK. Pick the deal. Pick the object. Choose OK. Now this has the desirable negative concentration. Try to get the same time windows. Now with a little creativity, it's possible to do this in the same simulation. But it's just as easy, in my opinion, to show them side by side, except I'm not very effective at it right now. There we go. So it's 7 hours and 20 minutes after we have implemented our green infrastructure. We have a predicted output TSS of 126, and at the same time in the pre-development, it's 415. That is disturbing. The plots didn't look that different. So about a factor of 2. Let me check the plots. There's something goofy about those numbers. Okay, that peaks at 180. We go to the same location here. I bet I plotted the wrong variable. Okay, agree with that. See, it's plotting flow, it's not plotting the TSS. So if you're using the internal features of the program, check the columns carefully because it has a bad habit of doing this kind of thing. So I have selected TSS. I've got my link. I choose OK. And based on the scale, that now looks like TSS. So let's do the same over here. Go to my deal. Go to time series. Object, I guess. Click on TSS. Unclick on flow. Choose the okie dokie. And 7 hours and 10 minutes in both cases. Here it's 149 with treatment and 153 without. So we have a not much of an impact once we consider the entire watershed as a whole, but non-zero. So in an instance of a water quality permitting or credit gaining case, we can legitimately make the argument that our expensive controls have a detectable impact in the model, and hence they should be detectable in reality. And then how to sell a client or a regulator on 7 parts per million being worth the hundreds of thousands of dollars it would take to implement these things is a job for your political science that you've all taken a class in. We have one more area that we could that I admitted for you all to be able to use as a control area, which are these this furniture and food processing area and this portion of the highway drainage. And so we would proceed along the same approach. And I'm just going to assume that TxDOT will let us use all their highway. They're usually pretty good about that, especially if they're paying for it. And again, at this point, I'm just being somewhat lazy and parameterizing stuff. I already tried to do a group editing, and the LID controls does not come up as an object in group editing. So you have to do this in this annoying fashion, which kind of makes sense when you think of how this was originally intended to be used. We're using it at a scale that I don't think they've ever contemplated as being used at. I don't see any reason why you can't use it at a large scale. It's just that most studies to date have used the swim model as a way of explaining their field measurements rather than using it in our approach as a conceptual design tool. Different different end use application, but same underlying. Hopefully I got them all. And then we would make that change, save it, give it a new name, run the simulation. And we're pretty lucky. This simulation runs really fast for this size of a problem. I don't need two of those alive. Let me get to this guy. So 147. So now we've added probably another several acres of net infiltration gallery and got another 2 milligrams per liter reduction. So actually, I'm kind of impressed that assuming the numbers I've entered are realistic enough, that it has that much of an impact given the overall area. Okay, that's about all my throat can handle. It's starting to hurt now. Have you all started on this? Okay, well,
I just tried with the base case and it worked okay, but didn't experiment with the green infrastructure tools yet.
okay, cool. So assuming I miraculously get better tomorrow, what I'd like to do is we'll meet tomorrow evening for a short meeting like this one, not the full hour and a half. And since nobody's actually started it yet, why don't I give each of you a role? I'm going to let Anna pick her role because she's the odd woman in this group. Actually, the only woman in this group. You can either choose the Hughes Complex, Evergreen Cemetery, the Railroad Yards. Oh, Evergreen Cemetery is part of Hughes. Hughes Complex, Railroad Yards, or the Furniture Highway Complex, and make your best pitch at green infrastructure modeling them, or you can do all of them. So any one of those 4 choices, which would you like to choose?
Well, I started with the railroad, so I think I'll.
So you're the railroad lady, okay? He's going to do railroad. So there's 3 of you left. Anybody have a particular desire to do Hughes Complex or the furniture one? Weston, you do the Hughes Complex. Richard, you do the furniture and the highway. And Jawad, since you have all day today to work on it, when the 3 of you get something done, take your input file and send it to Jawad, and hopefully you can get that in time for him to put all of them together into the collective one. Does that sound pretty fair? Is that achievable in a 24-hour period between now?
Or Dr. Cleveland, I can experiment with the 3 as well. So I guess that would be better. Otherwise, I will have to wait for the other 3 to get back to me.
Okay,
So,
you go ahead and do that. What we can do tomorrow night is, as we look at each of your contributions, Jawad, if you make one that has all 3, we will just modify the parts of the input file so it picks up everybody's contribution into your example of it. I'll be able to walk you guys through that. It's not that, shouldn't be that hard. And that way everybody gets a swim modeling experience. And more importantly, gets the lovely experience of reading this kind of crap and figuring out how to put numbers in, which is what we do for a living. So
Just to clarify, which one was my location again? With
what'd I tell you?
Like where it was located?
You are Hughes Complex?
Yes.
I will draw a polygon around it on this picture. So the Hughes Complex would be pretty much all of this area.
Okay.
So all the white area in here, plus this little bit of green part, which is the skull orchard.
Okay.
And just to give you some perspective, This is a Hughes tool facility. They made drilling tools, so there's a lot of metals processing in there. I showed you the metal recycling aerial image last time, and down in this area is the Metro bus barn. That's where they take all the broken Metro buses, fix them, repaint them, and then put the TV commercials that tell you what the wheels on the bus do. You're from Houston, so you know what the wheels on the bus do, right? Where do they go?
They crash into other cars.
The wheels on the bus go round and round. That was what the TV commercial was to try to get the ridership up.
Oh, I was talking about how Metro just likes to hit other cars all the time.
They are accomplished at that, but that's easy to do in the Houston area. I mean, it's a target-rich environment from that perspective. So that's your area. And then Richard, yours is these three subcatchments plus let's go ahead and give you the high school too. So all that dashed area is the area you have to work with. And then Anna, you've already worked up in here. And then the rest of it we leave alone. And your parameters are whatever devices or way you approach it. You can't use more than 25% of those contributing areas because you still got to leave room for the buildings and the buses and the high school kids. So we can't completely wipe out the whole area. Although I think in new development, if it hadn't been built yet, that's actually, it would be feasible to design something that could be both a green infrastructure device that covers an entire area as well as some other device such as a building that you can live in. But you'd have to think of that ahead of time. So we're doing retrofit engineering here. So we can muck up to 25% of our drainage area in those regions. And our goal is to see how much we can affect the TSS in the runoff at one of these downstream points. I would suggest that actually, since once we include the Metro bus barn, we'll do compliance in this last conduit 282. And the other thing to look at is to see what effect, if any, it has on the runoff signal. It might decrease the peak slightly. And we have a fairly stupid rainfall input that's not very interesting, but we're just teaching ourselves how to use this computer program. So that's your task for tomorrow night. And then you guys will share it with me, and I will steal as much knowledge from you as I can while you're talking. And that way I'll have an effective model. And then when we're done, I'll have you all email me your input files, and I will collect them and put them back on the server for everybody to cross share. All right. And that's your second assignment. So I expect great things from you by tomorrow. And just so you don't get blindsided, I'll give you warning, more warning than we gave Anna when she gave us her research presentation, completely unprepared, is I will ask you all to present one at a time each of your results. I'll give you control of the screen and you can show us what you did. Okay. That's all I have for tonight. I am looking forward to taking something from my throat and something to knock me unconscious. And I'm an elderly gentleman. I have stuff that does both of those things. But taking it before doing a Zoom call would have been stupid because you would have watched me pass out here at the desk in a big old puddle of drool. So I will see you tomorrow night. If I feel too sick, I'll get an email out and we'll defer it to a later time. After these presentations, the last thing we're going to do is we're going to look at one other computer program called Storm, which is a true and correct two-dimensional riverine model system. And we'll just do a couple of tutorial kind of problems out of that so that you will have seen one. I'll warn you ahead of time, Storm is a time burner. So when you get it up and running, you go ahead and you let the model run and you leave your computer and you come back an hour and a half later to see if it's done or if the program crashed. And it's well-engineered program. It does both. Sometimes it gets done and sometimes it crashes, and it doesn't give you much warning. You can sit there and watch it do screens and screens of output. All it puts out is numbers, columns and columns of numbers. And then you'll start to see one number driving negative or driving to 0. And you're thinking, wow, I've done 800,000 of the 1 million iterations I want. Maybe it will stay stable to the end of the simulation run. And sometimes it will, sometimes it won't. It's a not quite ready for prime time program yet, but it's free. And I know how to operate it. So that's why we'll explore it. But for engineering practice, there are better tools than Storm out there, but I don't have them. So we'll look at that, and the principles are the same regardless of the tool. And so we'll look at a couple of tutorial examples, and then I will use some input files that we made last year for, I don't know if you all know Kushal. He's recent PhD, just got it a couple weeks ago. He used Storm for some of his PhD work. We'll look at some of the example files that he built for that, because it's kind of cool what you can infer from it. So we will pick up with that, and that's how we will end the semester and land this awful long overseas flight that we've been on. Weston, I like your hat, by the way.
Thanks. I like it too.
When I lived in Houston, I had season tickets to the Astros. And
Cheater.
huh? Cheater?
14 teams were caught cheating. We're the only ones that got in trouble. Don't get me started.
Well, I had tickets to the Astros back when they were in the National League. Before they went.
That was a long time ago.
Yeah, before I went to
That
the
feels
American
like it.
League, where they have designated hitters and designated pitchers, designated cheaters, and yeah, many good memory of watching Houston snatch defeat from the jaws of victory. But anyway, good night, everybody. Jawad, have a great day, and we will meet again tomorrow evening. My help permitting.
Dr. Cleveland, can you upload this video? Will you be able to upload this lecture?
I will indeed. I will upload it to my YouTube site. I may not get the link built there, but I'll do my best.
Okay, I will check it.
All right. Good night, everybody.
Good night.
Be safe.
Thank you, Dr. Cleveland.